everyone, welcome back to High Tech Fun Study channel. In today's video, we're going to discuss about chemical reactions and equations, class 10, science, chemistry, chapter 1. So, let us start. What are actually chemical reactions? A process in which one or more substances, reactants, change into new substances, products is nothing but a chemical reaction. So it is a process in which a reactant, which means any one or more than one substances, they react to change into new substances called products, is called a chemical reaction. Now let us see some of the examples of chemical reactions. First example is rusting of iron. Rusting of iron. Here iron plus oxygen. Iron and oxygen are the substances which are reacting. So they're called reactants. These iron and oxygen react to give iron oxide, which is our product. Next example, burning of magnesium. Magnesium and oxygen are the two substances that react. Plus sign indicates that they both react to form magnesium oxide, which is MgO. And next, photosynthesis. Here, carbon dioxide and water are the two substances that react with each other to form two products here, not one product but two products, glucose plus oxygen. This is also in your chapter 5 life processes. So glucose is actually C6H12O6, whereas oxygen is just O2. Okay, so reactants are carbon dioxide and water, whereas products are glucose and oxygen. Now let us see indicators of chemical reaction. First indicator of chemical reaction is that change in state. So if you have to indicate whether chemical reaction has taken place or not, you need to have some indicators that indicate or determine that a chemical reaction has taken place. The first one is that change in state. You will observe a change in state when a chemical reaction has taken place. Next, change in color. Next, evolution of gas, then formation of a precipitate, and change in temperature. These five things need not to happen at the same time. They can happen differently also. They can happen in one reaction or in another reaction also. So next one is, what is a chemical equation? We have studied about what is a chemical reaction, examples of chemical reactions, and indicators of chemical reactions. Now let us see what is actually a chemical equation. So a chemical equation is a symbolic representation of a chemical reaction where the reactants are written on the left side and the products are written on the right side, and an arrow between them indicating the direction of the reaction. So in the chemical equation, what happens is that it is actually a symbolic representation of a chemical reaction itself, where the reactants, the substances which undergo a chemical reaction, are written on the left side, which is LHS, and the products which are written on the right side are called, and the products, which means the new substances formed, are written on the right hand side, which means RHS. And between both of them there is an arrow. It is this arrow indicates the direction of the reaction, in which direction the reaction has been taken place. This arrow indicates. So a chemical equation is nothing but a symbolic representation of a chemical reaction where reactants are written on left side, products are written on the right side, and arrow between them is placed to indicate the direction of the reaction. This is a chemical reaction, chemical equation. Now chemical equation is different from chemical reaction, right? Because chemical equation is itself symbolic representation of a chemical reaction, whereas chemical reaction is a process in which one or more substances react to form a new product. So the difference also should be known. Now let's see an example of a chemical equation. The example of a chemical equation is 2H2 plus O2, which means two hydrogen molecules combine with oxygen molecule to give two water molecules. Now, terms related to a chemical equation. First, reactants. These are the substances that undergo a chemical reaction. Products. These are the new substances that are formed as a result of a chemical reaction between the reactants. LHS, left hand side. Reactants are written in this part of equation. RHS, right hand side. Products are written in this part of equation. Arrow, it shows the direction or determines the direction of the chemical reaction in the equation. I hope you are clear with all these terms. Now let us see the types of chemical equation. There are two types of chemical equations: balanced chemical equation and unbalanced chemical equation. Now let us see the definition of what is a balanced chemical equation. So, a balanced chemical equation is a chemical equation in which the number of atoms of each element is the same on both sides of the equation, following the law of conservation of mass. This law of conservation of mass states that mass is neither created nor destroyed during the reaction. So, balanced chemical equation is nothing but when a chemical equation in the chemical equation in each side, which means LHS side and RHS side, if you take any element, that element is having the number of atoms that element is having in both sides of the equation. Like in LHS also it should have two. If example, take H2. If on the LHS it's having two atoms, on the RHS also it should have two atoms only. If it exceeds more than that, it's destroying the law of conservation of mass. So law of conservation of mass states that mass is neither created nor destroyed in the reaction. So a balanced chemical equation means in the a chemical equation in which the number of atoms of each element is the same on both sides of the equation, which means on LHS also same atom should be there of each element, and on right hand side also same atom should be of each element, same number should be there, not same atom, same number of atoms. Okay, so balanced chemical equation thus follows the law of conservation of mass, which state that mass is neither created nor destroyed during the reaction. Now let us see the opposite of it, unbalanced chemical equation. If you ask me what is the opposite of something, means what you will tell, you will tell the opposite definition. What is the opposite definition? An unbalanced chemical equation is a chemical equation in which the number of atoms of each element on the reactant side does not equal to the number of atoms on the product side, violating the law of conservation of mass. So here right hand side matlab ki reactant side, whatever the number of atoms of each element are there, they are not equal to the number of atoms of each element in the product side. So it violates the law of conservation of mass. So we need to follow the law of conservation of mass. That is the reason we will actually change this unbalanced equation into balanced equation. And also another point to note here is that unbalanced chemical equation is also known as skeletal unbalanced chemical equation. Now let us see how to balance a unbalanced chemical equation. Why we need to balance the unbalanced chemical equation? Because we need to follow the law of conservation of mass, which states that mass is neither created nor destroyed in the chemical reaction. To follow the law of conservation of mass, we have to convert the unbalanced chemical equation into a balanced chemical equation. Now let's see the steps to do it. First, write the skeletal equation, which means the unbalanced equation. Second, balance. First you need to balance metals, then non-metals, then hydrogen and oxygen atoms. If you remember this order, you can easily balance any unbalanced chemical equation or a skeletal equation. First you need to balance metals, and then non-metals, hydrogen and oxygen atoms. Next, verify the balanced equation. After you balance them, you also have to write the states or any temperature in between, like 340 atom in the presence of 340 atom, and you also have to write like state the solid or liquid, like that. You need to write states of each element, and also above the arrow you can write like in the presence of chlorophyll. In photosynthesis you can write, right? In photosynthesis what you will write, in photosynthesis you can write here, when you write here the whole equation this side, above the arrow you will write chlorophyll and sunlight. So this means that in the presence of chlorophyll and sunlight, so in photosynthesis we will write like this. Okay, so like that, for some of the equations you need to also write states like solid. For each element you can write like solid, which if it is solid, solid, liquid, liquid, and aqueous form means, aqueous means water, water and liquid, gaseous form, not gaseous form completely. Aqueous means water kind of form, like a solution, aqueous solution when you mix any solid with water. So like this you need to mention some of the things required also. Okay, so next one is that example. I'm giving you a question, tell me in the comment section below after you solve this. Balance Na plus H2O gives rise to NaOH plus H2. So let me balance here only for you. So let us see how do we balance this. First, as we know, we have to balance metals. So here, if you see the skeletal equation, first write the skeletal equation. Na, sodium plus water gives rise to sodium hydroxide plus H2. Na this side is having one atom. Na that side is also having one atom. H2 this side is having two atoms, but H2 here is having three atoms. So what do you do here? First, let me write this equation, then I will tell you. Okay, sorry for that. So here what do you do? Here H2 atoms are there, but here H2 plus H, which means how many atoms? 3 hydrogen atoms this side, but there only 2 hydrogen atoms. So here we will write 2. So 2H, which means 2 plus 2, 4. And here also we will write 2, which means 2 into 2, 4. So here 4 hydrogen atoms, here also 4 hydrogen atoms. Now next one is oxygen. Is oxygen same in both sides? Yes, two oxygen. But now, as you see, Na is changed. Here Na is 2, here Na is only 1. So keep here also 2. And that's it. The balanced chemical equation for this is 2Na plus 2H2O gives rise to 2NaOH plus H2. Now, if you can also write states like solid and your liquid, like that, you can write states also. So this is how we balance this. And before going to the next session, thanks for watching the video till now. And if you like the video till now, please subscribe and like. And let's meet in the part 2. We have seen some of the half part of this chapter. We will see next half in the next part. Thank you for watching this video till now and supporting us. Thank you so much.